Okay, so when we're dealing with quadratics, it's always great if it's in vertex form and we can graph it and kind of find a bunch of information. But the issue is sometimes that we're not given it in our y equals ax minus h squared plus k. Because we can also write a quadratic in what's called standard form, similar to what we have when we're talking about a linear equation, where we get y equals ax squared plus bx plus c. Now, there are steps that we can do to go from standard form to vertex form. And those are, we're going to factor out the a value. So when we're looking at this, we're looking at the number in front of x squared. Now, sometimes that could be a 1, so we don't really have to do anything. Then we're finding the value needed to make a perfect square. Okay, we're making a perfect square trinomial, which is what this part of our quadratic is, that x minus h squared. That's a perfect square trinomial. And the way we're doing that is we're halving our b value and then squaring it. Okay, after that, we need to add and subtract that value. Now, sometimes that's a little bit different because when we add in a number in front, it does change the value that we're adding, and then we factor and simplify. So when we're looking at some examples, so we're going to do 4 examples here. So when I look at this first example, my first thing that I want to do, okay, is we're going to factor out that 3. Okay, so that's going to become 3, and then we've got x squared minus 8x. Okay, we factored it out of a and b. I'm going to just make my pen a little smaller here. So after that, we've got 3. We write our x squared minus 8x. And now what we're going to do is we're going to half 8, half of our b value, and square it. Half of 8 is 4, and 4 squared is going to give me 16. Okay, now I also need to subtract 16 because I can't just add 16 and not subtract it. So I'm going to have plus or minus 16. But really, I don't want that inside my perfect square trinomial. And also, I haven't just added 16. I've added 3 times 16. So 3 times 16 is going to give me 48. So I've actually added 48 to this equation. Okay, so when we're looking at this, we need to then subtract that 48 and then subtract 1 because that was in the original equation. So now I need to factor. So I'm going to take the square root and square root, x and 4. And I need to bring the sign down that was there. So this would be x minus 4 squared minus 49. Okay, let's look at another one. So if I did this one, we're going to factor out our a value from the first 2 terms. And this one, the numbers are a little smaller, so it works a little nicer. Okay, if we've got this, I'm going to take half of 4. Half of 4 is 2. Squared is going to give me 4 again, but it's plus 4 because we're squaring a number. And then really, remember, we have to think that we've actually added 8 because if I expanded this out, this would be 2x squared minus 8x plus 8. So I haven't added 4 here, I've added 8, so I need to subtract 8 outside of the brackets plus 5. Now we factor that value. We've made it a perfect square. So you should always have x. You should always have the square root of the last number and squared. All you have to remember is that it's the sign of that middle term. And then that's minus 3. So now if I move over here, this one's a little bit different. Obviously, we have a negative sign, but we treat it the exact same. Negative 2. We've got our x squared. Negative 2, we're dividing that out. So what we're going to have is negative 2 here because 2 negatives make a positive, plus 5. So I keep my negative 2, x squared minus 2x, and then half of 2 is 1, and 1 squared is still just 1. So we've got our plus 5, and normally we would say, okay, well, we're going to minus 2 because we've got our 2 there, and you don't have to draw that arrow. I'm just showing you. But negative 2 times 1 is actually negative 2. So if we have a negative out front, this value, we actually have to add outside. Okay, so if I looked at that, I'm adding 2 instead of subtracting it, because this tells me that I've actually subtracted 2 within the brackets here. That would be a minus 2 if I expanded it out. All right, so we're going to have negative 2. Square root of x squared is x. Square root of 1 is 1. We square the bracket. We bring down that middle sign. Then plus 7. Okay. This one, a little bit different. It just has the negative out front. So this one would be negative x squared plus 10x. We just changed the signs, close that bracket, plus 14. Now we're going to have negative x squared plus 10x. Half of 10 is 5. 5 squared is 25. This negative means that I've really subtracted that 25. I haven't added it, so I need to add it back in. Plus 14. So I'm going to get negative x 5 squared, and this is a plus this time, and then plus 39. And that's the answer. Now, if I had that exact same one, this is kind of the most basic one. So if I had something like this, y equals x squared minus 10x plus 14, when I'm going through this, I'm factoring out the a. I've got x squared minus 10x. Because there really was no a value, so then it's going to be x squared minus 10x plus 25 plus 14. But in this case, there's no a value, so I just have to minus 25 outside. So then I get x minus 5 squared, and then negative 25 plus 14 is going to be minus 11. Okay, we're going to work on question E in the warm-up tomorrow. If we look at this one, we now have 2 equations for this. So this is all referring to A. A is 3x squared minus 24x minus 1. So we get y equals 3x squared minus 24x, and it was minus 1. Or we had y equals 3x, not x squared, but 3x minus 4 squared, and we had minus 49. So if I wanted to look at this, state the equation of the axis, well, that's going to be here. Okay, that's the x value for my vertex. So that's x equals 4. My y-intercept, I just make x 0 in either of the equations, so I would choose this one, and I would get my y-intercept to be y equals negative 1. My domain is always going to be negative infinity to positive infinity. My range, this is facing up because I have a positive a value. So my range is going to be from negative 49 to infinity, and then 2 other points on the parabola. All I would do is pick any x and find my y. So if I picked, say, x equals 4, I'm picking that for a reason, but I would do y equals 3, and then I would have 4 minus 4 squared minus 49. So then I would get 4 and negative 49. Okay, that's my vertex. And then I could say like y equals 3 and then 0, 4 squared minus 49. So we're going to get 16 times, so this is going to be 3 times 16, because negative 4 squared is 16 minus 49. So we get 48 minus 49 is negative 1. So then I would get 0 and negative 1. Okay, and you can choose any value for that you want. We're going to take up E.